Right, so the first problem from last weekly contest, find x sum of all key long subarrays part 1. We're given nums and n integers, uh, nums with n integers, k is 6, k is the window size. So for this window size, what we need to find is top x frequently occurring elements. So here top x will be 2, so 1, 1, 2, 2 will be the top 2 frequently occurring elements, and I want the sum of those, so 1 1 2 2 will be 6. Here the top two frequently occurring elements will be 2, that is occurring 3 times, and among them 3 and 4 are occurring 1 time, so I am taking the larger element that's written in the question. So 2 2 2 6 plus 4 10. Similarly, last one will be 3 2 times, so 6 plus 3 2 times, so 6 12. Since this is the first question, it's brute force. We can do brute force because the constraints are low. So essentially what we are going to do is, for every window, I get the sum as I go, and since I want to uh, get the sorted in terms of frequency, right? Uh, Sorted elements in terms of frequency. So I will get a set. So in set, I can just have a pair. A set is ordered, and in C++ it is based on the first element, and then if they are equal, then it's on the second element. So I can have something like a pair of count comma value, so num. So this will give me, suppose for this window, it will give me 2 times 1, 2 times 2, or 2 times 1, and 1 times 3, or 1 times 4 actually. First will give me 4, and then 1 times 3. Now since I want the top 2, so I will remove it. So I already have sum of 13, which is the total sum. As I go, I calculate it. So sum is equal to 13, and since I am going to remove this, so 1 time 4 and 1 time 3, there will be 7. I'll remove 7, which will give me 6. So that's the answer. I'll keep doing this for every window, but since I'm going to erase it, I want the key so that I can erase it, right? So I want the key of pair count comma num. How will I get count? So for that, I will also have to have a map that will contain frequency of element within the window, and I'll do this for every window, and let's do it. N is equal to nums dot size. So I am going to have to get the window, right? So I can put j here, and then here, and then here. So this will be basically from k minus 1 to uh, till n, right? So basically j is equal to k minus 1, j less than n, j plus plus. So this is my right border of the window. So the left border will be basically I minus k plus 1. That will be my right border, because because j minus k plus 1 will be my left border. So if this is confusing, let me write it. J minus k, so j will be k minus 1 initially, so k minus 1 will be minus 1, so I have to do a plus 1. So this will be the right border initial value. I less than equal to j, because j is always valid, and that's it. That's my left border. Yeah. So for every window, I will have a sum calculated. I will have a unordered map, because for map I don't care about the ordering. Alright, and then I will have a ordered set, so a set of pair. Alright, as I go I will increase the frequency. uh, I will increase the sum. I will increase the frequency as well. But before increasing the frequency, I should delete whatever, if there is a set, if there is a key with frequency nums of I and nums of I, right? If there is a key of frequency nums of I, comma, nums of I, if there is a key present, then remove it. Alright, and after increasing the frequency, insert it. So I've increased the frequency, now I'm inserting the new key. So by the end I will have set, but there may be more values than x. I want the top x, so I will keep removing it and subtracting the sum. So essentially, as long as set.size is greater than x, I will subtract it from set, but from where? So set is basically from you know, the first element will be the smallest, and this will be the beginning. So from here I need to remove, this is the ending. From beginning I need to remove it. So I will get the key and erase it. So how will I get the key? From beginning of the set I get the pair. So smallest frequency, smallest num. I'm sorry, this is what we need to remove from the set, and I will subtract this multiplied by this, because this is frequency and value. And finally I will insert it inside answer. So every time, for every window, I'll return the answer and then return answer. And let's not forget to uh, declare answer vector, and let's see if this works. Okay, frequency, this should be frequency. Let's talk about time complexity. Time complexity for every window. So we are doing O of n square already. That will be the dominant expression, and space complexity will be O of n again, because certain frequency. Second question is a binary tree question. Kth largest perfect subtree size and binary tree. So we are given a root of a binary tree, a k value, and we are asked to find basically the kth largest perfect binary subtree. Alright, so let's simplify it. Using this example, we want the number of perfect trees. Among them, we want the kth largest, right? So this is a perfect tree of size 3. This is a perfect tree of size 1. What is a perfect tree? Well, perfect tree is one which has equal number of children and they are of same level. So none of them is missing, right? So this is of 3 size, this is of 1 size, this is of 3 size, this is of 1 size. So if I sort it in terms of the sizes of the perfect binary trees, so this will be 3, 3, 1, 1. What is the second largest? That is 3. That's our answer for this question. For this one, the entire thing is a binary tree. So if I sort it, it will be 7, 1, 2, 3, 4, 5, 6, 7, 3, 3, 3, 3, 1, 1, 1, 1, so 1, 1, 1, 1 for the children. So what we need is the first, so 7 is the answer. So here what we can do is we can, let me take the pen out. For every, we can do a traversal. First we go to the left, then to the right, then to the root. So by the time I reach the root, I will have the left and the right portion. What will we return? We will return the size itself, 1, 1. But should we return something more? Should we return if it's a perfect binary tree or not? Because there might be scenarios where I'll return 1, 2, 3, 4, 5 from here and 5 from here, and I'll reach here and I'll see 5 is coming from here, 5 is coming from here, so this must be a perfect binary tree. So I would have returned 5, 5, 10 plus 1, 11, but that's wrong. That's wrong. So I should return something more, right? I should return 3 with a true. I should return 1. This will be 3 or 3 and 1. So maximum I will transfer. So there will be 3. So in cases where the count is unequal, I'll return the maximum above. In cases where they both are equal, I'll return uh, the value along with the true and false case. So we are essentially returning a pair of count and a boolean value if it's a perfect tree or not. So that's the gist of it. And what to do about the kth largest? So that is simple. That's similar to the first problem because we are essentially doing the same thing, right? We want the frequency, or here we want the count in an ordered manner. So I can basically capture two things for every return from the left and right child, and that two things will be a map, a ordered map for the distinct counts of perfect trees. And I also want the number of elements inside map, so that I can only I can only, or I can uh, keep track that, or make sure that there are only key elements inside map. That's why I need this. Alright, so let's do that. We want the map, right? So I want a map which will contain int comma int. I want a count which will contain initially 0. I'll be calling solve function. This is a recursive function. Along with this, I'll pass k. I will return something something. Let's see what we'll return. First, let's do the solve function. So solve function will return a pair of int comma boolean. Alright. So this will be passing arguments as root k, and if root is null, so which means I'm here or here, right? I will return 0 and true, right? That's it. So return pair of 0 comma true. At this point I'll call for the left half, for the right half. This will give me a pair of int comma boolean for the left half, which I'll capture it in here, count and perfect L. This is a boolean. And similarly I get it from the right half. So I'll name it perfect R and count R. Alright, at this point I will want to add count L and count R. If perfect L and perfect R are true, I want to add it inside map, right? And I want to update this. So I will check if count L is greater than 0, because it can be 0 as well, right? I'm returning 0 for the base case, which I don't want in the map. So I'll have this, and if perfect L, so I want to have it only for the perfect cases, right? Then I will add it inside map. So num, sorry, inside map. So map of count L plus plus. So I'm keeping track of the number of distinct count for the perfect cases. And I'll also keep track of the number of elements. So count is what I'll increase. Similarly, I do this for the right half, for the right half. At this point, I want to balance the map as well. I want to return the things, but before that, I want to balance the map. What do you mean by balance the map? Well, we want only key elements, right? By the end, we want only key elements. So we can balance the map as we go forward, right? Or I can do that later on as well, but you know what? Let's do it later on. That will be better. So right now we'll return uh, based on count L and count R, if they're equal or not, and perfect L and perfect R, if they both are perfect or not. Like in this scenario, they both are perfect. This is returning 3, this is returning 2. At this point, it will become 3 plus 2, 4 plus 1. The root itself will be counted 5, and that will be returned 5 comma true. So return pair of count L plus count R plus 1 comma true. Otherwise, I return max of count L comma count R comma false. Alright. So at this point I will also get it for this whole binary tree, the same thing, that is count comma perfect, and I will process the map now. So what do you mean by processing? Well, I will keep removing the things from the map as long as the number of elements inside map is greater than k. I will keep removing it from the map. How will I remove it? Well, I will, since this is ordered map, right, and the smallest element will be in the beginning, I want to remove it from the beginning. Alright, so I'll get the frequency or the count value or should I name it? What should I name it? Well, number and frequency probably. Map.begin. This will be checked. If frequency is equal to 1, then I can straight away erase num. Else, I can erase it one by one. So frequency or num minus minus. At this point, I will have the things, but at this point there will be scenarios where in the question there will be scenarios where k will be greater than the uh, sum of or the count that we'll have in map. So in cases where k is greater, we can't really do anything. Even if we count all the perfect trees, we are not going to have something equal to or greater than k. So in that cases, we need to remove or we need to return -1. So if count is smaller than k, return -1. Otherwise, return uh, map begin, right? Map dot begin first. So this will be the largest kth element inside map because that's how I am treating the map, right? I'm removing all the elements till k from the smallest, right? So that at the end I will have the smallest as the kth largest. So that's it. Let's see if this works. So perfect L. I have some spelling mistakes. There is some more spelling mistakes. Now let's see if this works. Okay, semicolon is missing. Alright, there's some problem. Yeah, my bad. I should have added this count as well, right? Uh, Based on for the entire binary tree, I'm missing the count to be added to the map. So I will add that if it's greater than 0 and if perfect is true, only then I will add it inside map. So if these conditions are true, I will add it and I'll increase the count as well. Let's see if this works now. Uh, Time complexity and space complexity will be linear because we have a map. Yeah, it'll be linear, and that's probably it. Actually, since this is a map, by the way, since we are inserting and deleting, so that will be a login operation, and we are doing it for every. In worst case, we are doing it for every node. So it'll be O of n log n if we look at it carefully, and space will be O of n.